in general is called functions and graphs, and there's a whole lot of different things in here. Some just like regular like linear equations, definitely quadratics are in here again, square root equations, but just overall functions and how to deal with functions. Some of this stuff should definitely be maybe vague memories from algebra 2, but some of it might not be so new stuff. But today is called modeling and equation solving, which means AKA maybe some story problems today. Everyone's favorite, right? Everyone always says, how can you use math? And then you give them story problems, and then they still complain.
Story problems are not very much fun.
But then sometimes story problems are not very real life examples, like you're going to see in a minute, like who really figures this stuff up. But
85, I give someone 50, how many could I have?
right.
Who has that many apples?
So a table, we use that a lot, like XY chart when we start graphing, but any kind of mathematical data can be represented using a table, a graph, or an equation, and we'll use all three of those ways. In calculus, we like to say that this is, we call this the analytical way, an equation. This is the graphical way. This is the, I forget the way, table way, I don't remember what the, I don't know. And then the fourth way that we deal with in calculus is verbal, which means you have to learn how to write your answers in math class. So how can math get any more exciting? You have to be able to write about math as well. So, I know, isn't that exciting? Well, it just depends. Like, I think college algebra is a good choice, but it depends on what you're going to go into. Like, if you're going to have to take calculus in college, like, you should take calculus in high school because it's going to make college so much easier, even if you don't get AP credit. Because we do in AP calculus, we go a whole year for what you do in college in one semester. So we go like twice as slow as what they go in college. And so if you're going to have to take calculus in college, it makes no sense to not take it in high school because it makes your life easier. It might make your high school life harder, but it makes your college life that really counts easier. A lot. Like we spend 3 to 5 days on every lesson in calculus. So like we just did section 2-1 for 3 days. And sometimes we spend 5 days on one section, and they do 1 to 2 sections a day, which just means they cover a lot more. And the same thing about college algebra. We're doing college algebra a whole year that's only a semester course, and so that's what makes college algebra a lot easier here than if you actually took it at college. They're going to cover all that stuff a lot quicker, and so that's why people struggle with it more. So, you know, you could just be cool and take both.
We could be that cool.
You could be that cool. That's what the cool kids do. That's what I heard, at least. Word on the street. The street says it's cool to take both. So how about this? Here's a story problem for you that I'm sure you think about a lot. A pizzeria sells a rectangular 20-inch by 22-inch pizza for the same price as its large round pizza with a 24-inch diameter. If both pizzas are the same thickness, which option gives you the most pizza for the money? I bet you think about this every time you go to a pizza place, right? I'm just going to guess. Don't look at my picture and go by the picture because I hope that you learned.
The rectangle.
I hope you learned in geometry class not to trust the pictures because pictures are not always drawn to scale. It's just for reference. So you could definitely shorten this up. You could just be like, you could just draw a rectangle and say 20 by 22, but since this way, I'm going to go this is 22 and this is 20. Just because it's sort of like I didn't make that side longer. And then you could draw a circular pizza. If you want to be really cool, you could draw some pizza on it. And we could say that it's a 24-inch diameter. So we'll just do 24 inches here. And then you could just write which is more. That's the super shorthand way of writing that problem. Sometimes I think that we failed you in high school. You guys think you have to write every little word that's in the notes, and that you're going to go to college and they're going to just go really fast, and you're going to be trying to write on every single word. So I try to teach you how to shorten things as you go. But then sometimes you shorten it so much, and you go back to study, and you don't even know what it means. So you have to learn the balance there.
Why can't you just take it out of like?
That's because you have a chicken calculator. You should be able to like hit approximately or something at some point, right?
No, there's no
most pizza? What are you doing, Zane, on your calculator there? What are you actually trying to find? You're using what formulas? Which is what of a circle? Area, right? If we want to know which pizza has more pizza in it, we want to know which one has more area is what we're looking for. So you're right. This is pi r squared. And what's area of a rectangle? Oh, length times width. See, it's a good Friday day. I like to build you up, right? Start off nice and easy. That's just how math works, you know. So a 20 by 22 inch pizza gives you 440 square inches of pizza. And now we need this in a decimal, right? This is the one time that decimals are my friends, because if you give me an answer in terms of pi, I can't really compare those so well. So story problems are the one time that I think decimals are acceptable. So I put 24 in here. So that's my diameter, right? So our radius would be half of that. So 144 pi. And if you use 3.14 on this, you're going to get close enough. But if you use the pi button, you get 452.39 square inches. So Colin, you picked the wrong one.
Well, I was just basing it off the picture, so it's a good thing you told me that.
Never trust a picture, ever, in math class.
So, like,
What did you get?
144.5.
But that didn't tell you, did that tell you which answer to pick? No. So maybe just take 144 times 3.14. 159, 26535, 8979,
Whatever that number
323, 84626, 533, 23, 279.
You can just be like saying random numbers.
That's all I know. I only noted that. I noted the third line of numbers.
You can just be like 1, 7, 6.
You were a cheater.
Oh, I think I missed one. I said 433. I don't know if I said 8. I forgot.
You cheated. I don't know.
What? Yeah. I ended with 5. I think I said 5 there, but. No, that's how I learned it really fast. So what's the answer here? Which pizza gives you the most for the money? The 24-inch diameter. Or you could say the circle pizza. That's probably why pizzas are in circles, because you get more pizza than with rectangular pizzas. Who makes rectangular pizza?
Well, it makes sense. It fits more into the box.
Chicago, so they make that great big giant pizza. Is it a rectangle?
You can get more.
Is the circle that great big one?
Yeah.
No, what I'm saying, you could get more pizza if it were more sided.
There's
You
some
could fit it in your box.
Right, you wouldn't be wasting so much box.
Yeah, exactly.
I'm with you.
You're not using so much
Package.
cardboard. Yeah,
Right.
that's right.
That new place in Greencastle, they have
If they made a circle box, that'd be convenient for them.
When I was a kid, Little Caesars had the Bigfoot pizza, and it was a great big long rectangular pizza. It didn't even come in a cardboard box. It came in like paper. Like you just ripped the paper in. But that was back in like 1994 when you were not born. We talked about quadratics in chapter P, but quadratics are not going away from us. Today you're just going to have a bunch of mixed up equations, and some of them are going to be quadratic. So hopefully you did this right on your test yesterday, which means you'll do great on these today as well.
I mean, I have a question.
Yes.
Okay, this is kind of like our test yesterday. Like, whenever you only have one answer, do you write it in like interval notation?
The only time you do interval notation is when you have an inequality. So when you see an equation, you don't have to do interval
Well,
notation.
you used to like put them all in there, so I was like, let me just put these little brackets around this answer.
Right. Which you can, but that's not, I mean, it's not really an interval, so you don't have to do that. Like you can just say like x equals 7. It depends on if it's an and or nor, right? Oh yeah, it's just two separate answers. You just have it. So if I'm going to solve this, what should I do? Yeah, I'm going to get equal to 0. And then you have three options. You can factor, you can complete the square, you can do the quadratic formula. Complete the square would be a great one on this one because there's nothing in front of here, and this is a lovely even number. So I guess I didn't need to move that 8 over. I'm going to move it back over. And complete a square, I'm going to take half of this and I'm going to square it. Half of 4 is 2, and 2 squared is 4. And if I add 4 here, I have to add the same thing over here. So remember that when you complete the square, it should now be a perfect square trinomial. You can factor this, and it should be the same thing twice, or it's always half of that middle number. So half of 4 is 2. X plus 2 squared gives you this. And then from there, we should be taking the square root of both sides. And then usually where we struggle on chapter P is the simplifying. So I haven't graded that far yet to see how we did on the second page. But you want to always simplify your radicals if you can. If there's a perfect square in there, you want to pull out that perfect square. So this is the same as the square root of 4 times the square root of 3. So that would be 2 radical 3. And then I'm going to subtract 2, and I would get negative 2 plus or minus 2 radical 3. Oh my goodness. That's a bit out of control. I don't even know what that's supposed to be. Right? We just did that. Still doing it.
I don't know that part. It was when he was writing the perfect thing. And then he's like writing the C. He's like, I don't know about your first stuff.
Rudo.
There's R's? I thought it was C's.
Yeah,
He was supposed to write Z's, but he did like crazy things, and so the teacher said,
Yeah.
Rudo?
Yeah.
And then he got cried and ran out of time.
I mean,
Okay, so roots, zeros, and x-intercepts, you should know this, but it is super important. I think there's a test that you take in Algebra 2 where you had to list like all the ways, like what is the same as a root, and you had to write the zeros and x-intercepts, remember that? I only know this because I'm just going to start using my test, so I know what's on the test. Like I wrote the test and he still did. It does still, I agree. But super, super important that when you are talking about these 4 words mean the same thing. So I don't care if you write these word for word, but make sure that you know when you solve a function equal to 0, you are finding roots, also known as solutions. You are finding zeros. You are finding x-intercepts. Those 4 words mean exactly the same thing. So if you just want to kind of summarize what I circled and underlined, I'm okay with that. You don't have to write word for word if you don't want. But make sure that you know those are the same. If I say solve this equation, that's the same as if I said find the x-intercepts, or if I said find the zeros, or find the roots. Those are kind of super important vocabulary words that apply to all equations. It's also important because when we start graphing, lots of people know how to solve an equation, but then sometimes they don't know what to do with those answers. Those answers are my x-intercepts, so are my zeros. So I know where to graph those when we solve them. So I like to stress that a lot. Okay. I'm not today. But eventually, yes. You're going to be graphing in this class, so you need to just learn to accept it and love it. I have really nice graph paper that I give you. All right. You don't have to write this down. I just think this, I'm a math nerd, and so I think that this book is kind of funny. Hopefully you know for any story problem that you should sort of do this. This guy, Polya, he says that this is a 4 problem-solving steps. I think it could be used on any problem, like math problem, or, like maybe just your own problem that you have in your life. Understand the problem, like maybe, I don't know, what's the problem that you might have? You don't know whether to take calculus or college algebra.
Homework on a Friday.
Devise a plan. Well, what should I do? Should I take calculus? Should I take college algebra? Let's look at my options. Carry out the plan and look back to see if your answer makes sense. But the reason I put this on here is just because I know you don't read your book, and I'm going to just share with you that it says here that George Polya is sometimes called the father of modern problem solving, not only because he was good at it, because he certainly was, but also because he published a most famous book called The Problem-Solving Process. But I just find the author of this to be funny. Who reads that? How many of you would have ever read that? Never. But he published a book about it, and these were his steps in it. How to solve it, a new aspect of the mathematical method. So he got paid to write his book. And he was born in 1887, and he died in 1985. Good long life. I know. He's known. Maybe I'll put a question someday. Who is known as the father of the modern problem solving? Polya. Okay. Moving on to real stuff. Let's do another problem. Most math books are very boring, but this math book, they're kind of funny when they write their stuff. And so sometimes I share stuff with you.
I didn't even know it was right.
Something else that's thrown in here is square root equations, and again, it's just checking to see if you remember the algebra that goes with that. If you're solving a square root equation, the first thing you want to do is get the square root by itself. So this one already is. But if there was something added or subtracted out here, you want to make sure to move it over to the other side before you do your next step. Because how are we going to get rid of a square root in a problem? Yeah, to square it. If you square it when there's something added or subtracted, it's going to be a big mess. So you want to make sure you get it by itself, but then you're just going to square both sides. And remember, this is another thing that people tend to forget. This is not just 4x squared plus 25, right? When you square this, it really means that there's 2 of these. Oh, man, you forgot, didn't you?
No.
So you actually have to FOIL that out. So we get 4x squared. I'll just show my work here. Minus 10x minus 10x. That's minus 20x plus 25. And then over here, when you take a square root and you square it, those undo each other. So you're just left with x plus 4 on this side. And so what we've created is now another quadratic that we should be able to solve. So I'm going to subtract x, and I'm going to subtract 4, and I'm going to get 4x squared minus 21x plus 21. And again, when you get to a quadratic, factor, complete the square, quadratic formula. I wouldn't want to complete the square on this one because I don't want to deal with 21 fourths and all that stuff. I could do it if I was forced to do it, but I think I maybe would just do the quadratic formula on this one. I could try to factor, but I don't like dealing with thinking of big numbers. So maybe I'll just do the quadratic formula since some people still seem to forget that. Right, that's the quadratic formula. You have to know the quadratic formula if you're going to use it. At no point during a test or quiz will I tell you the quadratic formula. So I'm testing that you know it. And if you don't know it, then you just got to complete the square. Or factor, I guess, if it's factorable. So what would this be? Negative b, so that would be 21 plus or minus the square root of 21 squared. I don't know what 21 squared is. plus or minus in between it. You did not. I looked again last night.
Yeah, I'm not gonna lie.
You had this and then right as a square root.
No, I put the plus minus, that's all I have.
You did not.
Maybe it was-
Maybe you just knew the plus or minus was there, but you didn't write it.
Yeah.
That's what it was. Minus 4ac, so negative 4 times 21 would be minus 336 all over 2 times a, which is just 8.
I did have e squared times for it.
That's good. I got 105 under my radical. Did you get 105 under your radical? Yeah, 105. I don't think that's going to simplify. So that's going to be my answer. You got to be careful with square roots sometimes. You might get an answer that doesn't work when you plug it back in. This one's not so pretty, so I think it's going to be okay. But let me check it quick. Oh my gosh. 105 divided by 8. Sometimes, especially if you get nice answers, like not radical, you want to make sure that it works when you plug it in. Because remember that to be a solution here, we're not going to have anything imaginary. So if you got an answer that was like negative 5 for x, that would make that imaginary on this side. You agree with that? So square root equations have what we call, sometimes they have extraneous fruits, which means sometimes you do the math right and you get answers that do work, but when you plug them in and check them, they don't work. I just checked mine to make sure that the negative 1 is 1.34, which isn't even negative, so I'm good to go here. But if it factors out nicely to give you 2 answers, just kind of look up there and make sure that you don't get an imaginary number under the radical, because an imaginary number is never going to equal a non-imaginary number on this side. Okay, and I think there's one on your homework like that we'll probably talk about tomorrow. But this one is just a quadratic formula. Again, what you just did on your test, so hopefully you feel good about that. Questions about that? Oh my gosh, it's your homework. I want to talk about your homework because people always have issues about this.
Have you ever thought about taping your line up to the protector?
No.
So that it's not
It
like
would just fall down and hit me in the head. Last Friday you didn't have homework, so.
You could suspend it with like a paper clip in the ceiling, like a chain or something.
I could be super nerdy and just wear like boots. Oh, that would be cool.
Here, Mason. I'm trying to take them.
Maybe if you didn't keep corresponding equation at the bottom. So you can see choices A through J are all graphs, 1 through 10. Each one of those graphs is going to correspond to 1 through 10. And then K through T, each one of those equations is also going to correspond to 1 through 10. I think it's easier, I don't know, I tend to like equations better. So I tend to find the equation and work my way backwards. Like for linear graph, like look at P 3x minus 2. I know that's a y-intercept of -2 and a slope of 3, and I can use that to work my way backwards. I also want to explain to you how they give you the graph there. So look at A, and underneath A, it has that -2 to 14 by -4 to 36. That's the x and the y-axis. That's the bounds. So this one is your x-axis. So it's telling you that the x-axis goes from -2 to 14, and that the y-axis is going from -4 all the way up to 36. And so the windows are very helpful on this because otherwise you might say they all look the same, and you might struggle doing that. But hopefully you're able to kind of figure those out as you go. Also, for the table, if you know which equation goes with the graph, then you can just make an XY chart and find the table that goes with it and do that as well. So let's see if I can help you with one of them. Like, I don't know. Let's just look at number 1. Let's see if I can help you get started here. Eliminate some options here. Look at the table on number 1 and look at the y choices. Are the y's going up by a constant amount? So if your y's are going up by a constant amount, do you agree that that's going to be a linear equation? Well, that's because it skips from, instead of going by 3, you see how it goes from 12 to 15 now? Follow me on that?
It goes by.
You see how it goes by 2, and then the last one it kind of throws you off a little bit and jumps from 12 to 15 on the x. And so it's not going to be equal. You with me on that? Or you're not? Anyone else?
Just saying.
No, I added.
Right, like these are going up by 2, and then the bottom ones are going up by 4, but then the very last one jumps, the x is now going up by 3, so that's why the y doesn't match that. But if you can look at those first ones that see it going up, that's definitely a linear equation. And if it's going up, it's definitely linear, so you could go through and eliminate anything that's not linear as your option. You also could actually find your slope there if you really wanted to. How could I find, is my slope going to be 4? No. How would we find slope? It would be 2, because slope is rise over run. So like if you could take the change in the y's, 10 minus 6 is 4, over the change in the x's, 5 minus 3 is 2. Your slope is going to be 2. So look at that. Do we have any that have a slope of 2? Oh yeah, you're looking at graphs. I'm jumping to the equation first because I like the equations. Look at the equations and see which ones have a slope of 2. Q and S, right? So we're down to either Q or S. One of them has a y-intercept of 0, one has a y-intercept of 3. Could I just take one of those points, 3 and 6, plug 3 in, and which one do you get 6 out of? See what I'm saying? Like this is an ordered pair, like 3 and 6. Q is 2x, S is 2x plus 3. Which one of those, when I plug 3 in, do I get 6 out of? Only Q. You follow me on that? I'm kind of breaking this down like so. Number 1, Q. Whew, that was a lot of work. Now you got to find the graph that goes with it. It needs to be linear, it needs to have a slope of 2, and it needs to have a y-intercept of 0. Which one of those graphs has, I think there's only one that has a y-intercept of 0. Me. See that? You don't have to do this way, you can do the graphs first, but I like to find my equation, and then I go back and find my graph. So for each one of these, there's not really a lot of work to go with it. It's just kind of going through there. And there's probably a lot of writing in your book because people are ridiculous. to graphs and equations and seeing that they all can be represented the same way. So take a little bit and see how you feel on those. And maybe it'll be easier to fix, like go through the linear ones first. That's why I would probably just number my paper 1 through 10 and not necessarily go in order if it was me. Like go find another one that has a slope of 2, because there's only going to be one other one that has a slope of 2, and you know it has to go with S.